Ever get that feeling like numbers are kind of secretly in charge? Like they're whispering behind the scenes telling us what to buy, who's ahead, even how good a deal actually is. Well, today we're grabbing those whispers by the calculator and figuring out what they really mean. We're going on a deep dive, into comparing quantities. Sounds kind of textbooky. I know. But trust me, we're about to unlock some aha moments that make this way more interesting than just remembering back to math class.
Absolutely, yeah. This isn't just about memorizing formulas. It's about understanding how these concepts, ratios, proportions, percentages, help us navigate, everyday decisions.
Okay, so the textbook jumps right into definitions.
Yeah.
Like it talks about Hina and Amir. Hina's twice as tall as Amir, so their height ratio is 2.1. Pretty basic, right? But then I started wondering,
You want to know why it matters?
Yeah.
We get comfortable with the how of math without always asking the why.
Exactly. So why should we care about ratios and proportions? They feel kind of duck in math class.
Because they're how we make sense of the world when things aren't equal. Imagine you're baking cookies and their recipe calls for a 2.1 ratio of flour to sugar. If you just use equal parts, your cookies are going to be interesting.
Or like crunchy sugar discs, probably.
Exactly. Ratios help us maintain those important relationships between quantities, whether it's ingredients in cookies or the visual balance in a painting.
That's a good point. Speaking of visuals, the textbook mentions something about ratios in art.
Right. A sketch with pleasing visual proportions is often naturally appealing. And did you know many national flags use a length-to-breadth ratio of approximately 3.2? There's a reason that just looks right. It's about creating a sense of balance and harmony.
Huh. I never thought about flags in terms of ratios. See, this is what I love about these deep dives, unexpected connections. Speaking of connections, let's talk percentages. Those are everywhere, right? From screaming sale signs to those election pie charts. Are they always telling us the whole story, though?
Not necessarily. They're great for comparison, but can be misleading without context. Like the example in the text, Anita and Rita's test scores. Anita gets 320 out of 400, while Rita gets 300 out of 360.
So Anita gets more questions right, but her percentage is actually lower than Rita's. That's tricky.
Exactly. Without knowing the total possible points, those percentages don't give us the full picture. Got to remember to ask ourselves, percentage of what?
Right. It's like those 50% off signs that are 50% off a price they jacked up last week. Speaking of percentages in shopping, how do we actually use them in real life, like those sale prices or...
Well, let's break it down. The textbook gave a few good examples. Say we want to know the percentage of kids who like playing football. We ask 100 kids, and 25 say yes.
Then 25% of those kids are future football stars, or at least fans.
Precisely. Simple as that. Now imagine you're at a store and see a sweater on sale. The original price was 100, but now it's 75 to calculate the discount.
Hold on, before you dive into the math.
Yeah.
Why wouldn't you just know it's 25 off?
Because understanding the process helps you when the numbers aren't as neat and tidy. In this case, we'd subtract the sale price from the original, 100 minus 75, which is 25. Then divide that by the original price and multiply by 100 to get the percentage. 25 divided by 100 is 0.25. Multiply by 100 gives us our discount of 25%.
Okay, that makes sense. So even if we can eyeball it sometimes, knowing the steps is key.
Exactly. Now, what about when we're talking about buying and selling? Like that flower vase example from the textbook. That example helps us understand profit and loss. Imagine a shopkeeper buys a vase for 100 and sells it for 120.
Okay, so they made money, right? A decent profit.
Exactly. To calculate that profit as a percentage, you subtract the cost price from the selling price, which gives us a 20 profit.
Let me do the percentage thing again. Divide by the original price and all that.
You got it. Divide the profit, 20, by the original price, 100, and multiply by 100. That gives us a profit margin of 20%.
So kind of like calculating a discount, but in reverse. Instead of how much is taken off, is how much is added on top.
Precisely. And that concept applies to so many situations. Businesses use it constantly to make sure their expenses aren't eating up all their profit. Speaking of which, before we move on, that reminds me of another great use of percentages from the textbook. Remember the example with estimating shaded areas?
Oh, yeah, like that shaded rectangle. I remember trying that one myself. It's like a fun little brain teaser.
Exactly. It helps build visual intuition for percentages. And speaking of visual, have you ever heard of a tangram?
It rings a bell, but I can't quite picture it. Refresh my memory.
It's a puzzle with 7 flat shapes called tans that you arrange into different figures. They're a great way to explore geometric concepts and, get this, percentages.
Wait, really? How do percentages fit into a shape puzzle?
Because you can arrange the pieces to visually represent different percentages. For example, you can make a shape where 25% is one color and 75% is another.
That's so cool. I'm going to have to dig out my old Tangram set. It's amazing how these seemingly simple concepts can be so multifaceted. Okay, one last scenario I want to touch on before we wrap up. The textbook mentions Sohini's family getting a scooter, which leads to a discussion about loans and interest rates. I think we could all use a refresher on those concepts.
Definitely. Imagine borrowing money for something like a scooter. That money is called the principal. When you borrow, you usually have to pay back more than you borrowed. That extra amount is called interest.
Right, so it's like a fee for borrowing the money in the first place.
Exactly. And interest is usually calculated as a percentage of the principal. This percentage is known as the interest rate.
Okay, so let's say Sohini's family borrows $1,000 for that scooter, and the interest rate is 10% per year. What happens at the end of the year?
At the end of 1 year, they'd owe $100 in interest on top of the $1,000 principal.
So they would have to pay back a total of $1,100. That makes sense.
Exactly. And if they borrowed the money for 2 years, they'd end up paying a total of $200 in interest. This type of interest, where the principal stays the same each year, is called simple interest.
Simple interest. It sounds very straightforward when you put it like that. Although I'm sure it doesn't always feel so simple when you're the one paying it back. The textbook mentioned a formula for calculating it, IPRT 100. Can you break that down for us?
Of course. I represents the interest you'll pay. P stands for the principal amount borrowed. R is the interest rate, expressed as a percentage. And T represents the time period, usually in years. It seems a bit intimidating at first, but it just helps us calculate things quickly, especially with large numbers or longer time periods.
So in Sohini's family's case, the principal P is 1,000, the interest rate R is 10%, and let's say they borrowed the money for 2 years, T. How would we plug those numbers into the formula?
It would look like this. I, 1,000, 10, 2,500 bunder, which if you do the math comes out to 200, the same amount we calculated earlier.
The formula checks out. It's like having a cheat sheet for interest calculations.
Exactly. It gives you the power to decode those financial situations that might have seemed confusing before.
I love that. And speaking of decoding,
Yeah.
earlier you mentioned that percentages are used to express increases or decreases in quantities. The textbook uses the example of a school team and their winning streak. What was their record again?
Right. The team won 6 games this year compared to the 4 they won last year.
A definite improvement.
Yeah.
But how do we translate that into a percentage increase? Like, what's the formula for that?
Well, we compared the change to the original amount. They increased their wins by 2 games, right? So to find the percentage increase, we divide that change, 2 by the original number of wins, 4, and then multiply by 100.
So 2 divided by 4 is 0.5, multiplied by 100 gives us a 50% increase. That sounds pretty impressive, especially for a school team.
It does. Now let's look at a decrease. The textbook mentions the number of illiterate people in a country going down from 150 lakh to 100 lakh over 10 years.
That's a positive change for sure, fewer people illiterate. How would we calculate that percentage decrease, though?
Same principle, just in reverse. First, the amount of change. 150 lakh minus 100 lakh equals a decrease of 50 lakh.
Okay, so then we divide that change, 50 lakh, by the original amount, 150 lakh, and multiply by 100 to get the percentage.
You got it. That gives us a percentage decrease in illiteracy of, roughly 33.33%.
It's amazing how we can track these, large-scale trends and changes just by using percentages.
Absolutely. It gives us a standardized way to measure change, no matter how big or small the original numbers are.
That's a good point. It's all about relative change, not just the raw numbers themselves.
Exactly. And, that reminds me of something we were talking about earlier, businesses and profit.
Yeah, like that example with the shopkeeper and the flower vase.
Right. They might sell something at a 20% profit, but if their operating costs, things like rent, salaries, all that, if those costs eat up 30% of their revenue, they're actually losing money, even if it looks good on paper.
Wow, I hadn't thought about it like that. It's like there's this whole hidden layer of math behind every transaction.
Exactly. And that's why understanding ratios, proportions, and percentages is so crucial, especially in the business world. It helps you see beyond just the surface level and make more informed decisions.
It's like having a secret decoder ring for the financial world. This deep dive has been really eye-opening. We've gone from basic definitions to real-world applications of ratios, proportions, and percentages. I feel much more equipped to handle the world of numbers now.
That's what we want. It's about realizing these concepts aren't just stuck in textbooks. They're woven into our everyday lives in so many ways.
I completely agree. Well, on that note, thanks for joining me on this deep dive. It's been fascinating.
My pleasure. And for our listeners, remember, knowledge is power, especially when it comes to understanding the numbers all around us.